Today we are going to discuss about an important topic in aerodynamic drag in space environment. Before we are going to that, we know that drag means it is a backward force, and this backward force, it is opponent to the forward force, it is called as thrust. So in every object it will be having, or it will be goes and affect the atmospheric or some type of air. The four types of forces will be produced. The four type of forces are thrust, drag, lift and weight, and these four are also equivalent to, the thrust is equivalent to drag and the lift is equivalent to weight. So fine. Now this drags is how it will be incorporated or how it will be having the role in space environment. In any of the object, it will be having the 7.8 kilometer per second. Is any particle, it will be having or it will be affect with the atmospheric condition. It having the particular 7.8 kilometer per second. At that time, the drag will be produced in the space vehicle. So this produced drag, it can affect or it can affecting the factors like that following into the orbit region, that will affect the orbit region, and that will be having the re-entry of object. And this force is calculation is the equation force drag Fd is equal to half rho Cd in V square. Here the Fd is a drag force and rho is a density of the air and Cd is a drag coefficient and V square is a velocity of the air and A is the area of the object. So this equation will calculate about the drag force in space atmospheric condition. And the important one is satellite lifetime. So in any object, it will be having the how much duration it will be having the operation for that particular desired aim or goal, that is called lifetime. So here it is in a satellite lifetime. The satellite, how much time it will be taking for their entire duration of the life. So that is known as the satellite lifetime. Here we consider this is the satellite origin. This satellite origin, these are the semi-major axes it will be having included in the satellite origin. These aerodynamic force and aerodynamic drag in space, it will be having the controlled or uncontrolled mission. If it will be the uncontrolled mission, the satellite orbit does not follow this orbit region. It will be have orbit changes the direction of their space vehicle. So this is the major dependent on the aerodynamic drag in space vehicle, and this density of the air, it will be having the air must be in helium or nitrogen or some other gases will be encountered is here. Because of in earth we have to calculate the aerodynamic drag, it will be having the air particle. At the same time, it will be replicated into the space conditions also. And this velocity, already we said that it is a minimum velocity is 7.8 kilometer per second. So this velocity, when we have calculated in the drag equation, the velocity value is surely we know about that, it will be the higher value about 7.8 kilometer per second, surely not decrease or not in the less value of this. So in these important factors or these important parameters are, it will be having the high amount of vital role in when aircraft or astronauts will travel into the space through our earth. Thank you.